Welcome to Strive for Great Health podcast. I'm your host, Dr. Richard Harris, and a few updates. So we're not going to be releasing videos or podcasts over Christmas. We're going to take that time off and allow ourselves to rest, to recuperate, and to prevent content burnout, because content burnout is real. You know, right now we're producing about an hour of content every single week, and that takes a toll on you. So we preach rest here, we preach self-care, and we preach walking our talk. So we are going to take some time off, and then we'll be back in January 4th, with a great episode on the growth mindset. And I think that'll be very timely for starting things off in January when, a lot of people are wanting to make changes. But this is Wellness Weekly, and so we're going to be talking about our wellness journey called The Dancing Man, 2 articles, and then our supplement. This time is vitamin B6 or pyridoxine. So let's dive right in. The Dancing Man, our wellness journey for today. So this is a character, a really interesting gentleman that me and my wife have met walking our dog. And he lives at the veterans home right across the street. And every single morning, this guy's out there dancing, listening to his music, just loving life, full of happiness, full of joy. And, after last week's session of Be Like Bane, I realized that I should also be like Dancing Man. And he's dancing like nobody's watching, like just in his zone, in the groove, generating his own happiness. And I think that's so important. A lot of us look to the outside environment to bring us happiness. Because if you're constantly looking for happiness that way, you're constantly going to be disappointed. We have to self-generate our happiness. In fact, I say that happiness is an emotion, joy is a choice. And I choose to be joyful. Now, a lot of that is my faith in Jesus Christ, faith in the joy that he instills in us. But it's also the fact that I realize that no one else is going to make me happy if I'm not happy. There's zero chance that someone else can make me happy if I'm not happy. So I have to be happy in order for other people to make me happy. And that is joy. That's why I choose to be joyful. And dancing is one of the best ways that we can self-generate happiness. Have you ever seen someone look sad when they're dancing? No, it's a thing that we have done all throughout history. Dance is always there in different societies, different depictions, paintings, all of these things. There's dance. And I think that's so important that we do these dances. Even if you can't dance, just try. There's no harm in trying. There's no harm in just getting out there. No one's like, oh my God, that person's such a terrible dancer. It's just about effort. It's about trying. It's about just being your own source of happiness and joy, being your own joy battery. I don't depend on other people to fill up my joy battery. I do that myself. And what does the data say on dancing? It's really interesting. It's what we call a happiness double play. So dancing activates the sensory and motor circuits. It increases serotonin, the happy neurotransmitter. But music activates the brain reward centers. So you get this double whammy of happiness when you're listening to music and you're dancing. In fact, one study found it lowered dementia risk in elderly population. And multiple studies have shown that it improves outcomes in Parkinson's disease. Other studies show it reduces stress, improves brain plasticity, which is how your brain cells rewire. It improves executive function, memory, spatial recognition. I mean, this is all really, really good stuff. Who doesn't want that? Who doesn't want better memory? Who doesn't want better decision making? Who doesn't want a lower dementia risk? Who doesn't want improved coordination and balance? That's also been shown in the studies. And who doesn't want more happiness, more joy? I mean, if I polled all of you right now and said, hey, do you want these things? I think all of you would say absolutely yes. And it's such a simple thing that we can do to get it. And so what I try to do is I'll just dance in the gym. I'll do that all the time when I'm listening to my music. I'll just bust out into a dance. People kind of look at me funny, but whatever. I don't care. I do what's best for me and what's best for my family. I don't do stuff that's going to make me look cool or, cater to the opinions of other people. That's not what I do things. So do what is good for you. If you're at home and you're feeling down, just put on some music and dance. You'll see your mood improve dramatically. And it's something so simple. It's also like if you're feeling stressed, put on some music and dance. Watch that stress melt away. This may sound a little callous, but stop waiting for things to happen to you and make things happen. If you're feeling stressed, stop waiting for whatever's stressing you to go away. That's not doing anything, because there's always going to be something that's stressing you. Make that stress go away by you doing something. Smile, make yourself laugh, make yourself dance. These are all things that have a dramatic effect on our health and a dramatic effect on how we interact with our environment. So I'm hoping there's at least one person who, while listening to this, started to bust out in a dance. And if you want to, here, doing a little dance in my chair you can see on my YouTube video. Try not to make any noise so I don't wreck the audio quality. But that was me doing a little dance. Go check out the YouTube channel if you want to see it. All right, that was our wellness journey. Let's move on to our first article. The article is entitled Transcranial Low Light Therapy versus Sham Therapy. And sham therapy just basically means that it looks the same, but there's no active intervention being done among patients with moderate traumatic brain injury. So the introduction, traumatic brain injury, or TBI, is a major cause of death and disability. It's defined as an external force that impairs brain function such as memory, movement, sensation, and emotions. And the major pathophysiology, or what happens at the cellular level, is you get traumatic injury to the axons. Axons are the ends of nerves, and this is where all the signal transmission happens. The signal comes from the nerve cell body, goes down into the axon, and gets transmitted to another nerve. So it's like how signals get passed between different nerve cells. And so that what happens is when the brain accelerates in these traumatic injuries, you get a shearing of those axons. It's a literal shear force that damages them. And then certain other parts of the brain called white matter tracts are also vulnerable. And so white matter tracts are the covering of those axons. So they're the covering. It's a fatty covering. It's called myelin. Myelin sheath is what it's called. And that allows the signal to conduct faster. I'm not going to go into all of the biochemistry, but it would take a lot longer for a signal to travel if we didn't have these myelin sheaths, if we didn't have the what we call white matter tracts. So the low light therapy uses near infrared light to elicit a biological response. And what we think this is the light is absorbed by our mitochondria, specifically part of our mitochondria in the energy generation chain, an enzyme called cytochrome C oxidase. And what this does is it increases ATP production. ATP is how we generate energy. Without going too much into metabolism, just think about ATP as energy. That's the simplest way to think about it. It's also a signaling molecule, but its main purpose is for energy generation. But it also increases nitric oxide production. And we talked a lot about nitric oxide and what it does and why nitric oxide is great. In our nitric oxide podcast, I would refer to that, but nitric oxide is important for blood flow. It's important for immune system. So this low light therapy has been shown in previous studies to have vascular protection, so it protects our blood vessels, and neuroprotective functions, meaning it's helping to protect our brain. So this study wanted to look at the near infrared light therapy in the setting of acute traumatic brain injury within 72 hours. So what they did is they applied a helmet that did the low light therapy. They also did MRIs as soon as they could, then at 2 weeks follow-up, and then um, about 3 months after the trauma. So multiple MRIs, and they wanted to measure the integrity and the myelination in that white matter tracts we talked about, and they wanted to measure the integrity in the axons, the actual ends of the nerve cells. They also used a questionnaire called the RPQ questionnaire, which is the River-Mead Post-Concussion Symptom Questionnaire. And it basically measures physical, cognitive, and behavioral symptoms after a traumatic brain injury. So what they find, it was a small study. There was only 68 patients. They found that the low light therapy was safe and feasible. The TBI symptom severity was comparable between the two therapies, so it didn't seem like there was any adverse effects from it. In the brain imaging, it found that it was the low light therapy improved myelin repair, but not axonal repair. And in the discussion, it talked about that, this wasn't a pathophysiology study, but it appears that the process between myelin repair and axonal repair are a little different. So 2 previous studies with low light therapy showed some benefit in stroke patients. However, the third did not. The authors thought that the myelin repair and axonal processes were a little bit different. You can't generalize this to severe TBI. They also should have done a scan a little bit longer on, because what happens after injuries is you go through cycles of demyelination, remyelination. So that's something that they thought that should be done in further studies. And the study really wasn't powered to assess efficacy in improving the symptom burden, because there are so few patients. So what's the key takeaway from this study? The key takeaway here is that low light therapy in the situation seemed to improve some imaging characteristics associated with traumatic brain injury. It seemed to improve the process of the myelin sheath repairing itself. And so that's really cool. We'll need to see some further studies in this area, but this is another reason why infrared light exposure can be beneficial. And we're going to do an entire podcast on infrared therapy, what it does, how it affects the body, because I think it's a really cool technique, and I'm really close to purchasing a portable infrared therapy device for the house. So by the time we do that podcast, I'll probably have one. All right, let's move on to study number 2. This study is very, very technical, so I'm going to try to explain the key takeaways here for you without trying to go into being overtly technical. So the name of the study, and again, if you want access to all these studies, they are in our Strive for Great Health Facebook group. There's a link to a Google Drive that has all of the studies in there. So what's the study name? Microbiota modulated CART enteric neurons autonomously regulate blood glucose. Basically, 30,000 foot overview, the microbiome influences nerve cells, which regulates our blood sugar, independent of the brain. Wow, that's really, really cool. So let's dive in the introduction. So you have a second brain in your gut. We call these enteric neurons. These are nerve cells that function to help maintain the normal functioning of the gut. So it's mainly intestinal motility, helping things move through the gut, helping with secretion, things that we need to get into the gut to help us digest or fight off invaders. They receive information from food. Food is a signaling molecule. Food tells our body about what's happening in the environment. That's why you need to eat whole foods, not processed foods. Whole food signal environment's great. Processed food signal environment's bad and leads to a whole host of chronic diseases. But there's also other signaling molecules. How the nerve cells and bacteria and the gut cells talk to each other. Those are signaling molecules. It also receives information from immune cells and the microbiome. We talk a lot on this podcast about the microbiome. Why? Because the microbiome is so important. So recent evidence shows that the microbiome influences the activity of many intestinal cells, including the nerve cells, the immune cells, and metabolism. So this study wanted to look at how the microbiome interacts with enteric neurons to determine, is there an impact on host physiology? Is there an impact on our own processes at the cellular level? And one of the things that we know is that the density and diversity of the gut microbiome increases as you go further down the intestine. So what did they find? They found that the concentration of enteric neurons is higher as you go down. So it found that the concentration of the nerves in the gut increased in parallel with the gut microbiome density and diversity. They also found there was a significant impact of the microbiome on gene expression in a part of the intestines called the ileum and another part called the colon. They also found that some of that programming, some of that gene expression was microbiome dependent. Some of it was microbiome independent. So again, this is corroborating previous research that shows that our microbiome influences what we do at the cellular level. It influences what genes are expressed and what genes are turned off. So next they treated the mice, this was a mice study, with antibiotics, and they found certain types of the nerve cells decreased with certain antibiotics. So the antibiotics killed off the microbiome, which decreased nerves in the gut. That's a huge finding. And this is one of the problems with inappropriately prescribing antibiotics. People, if you have cold symptoms, stop asking for antibiotics. You are damaging your body. It's a virus. 90% of the time, it's a virus. Those symptoms can take 7 to 10 days to go away. And going in there demanding antibiotics for a viral infection, you're killing off your gut bacteria. You're causing dysbiosis. It's a major, major problem, especially in kids. You know, data shows that antibiotic use before the age of 2 is associated with asthma, allergies, and chronic disease. So really, we need to stop using antibiotics for viral infections. Most of it is upper respiratory tract infections, and they are, for the large part, viral, and they can take 7 to 10 days for the symptoms to go away. You're not treating your virus with antibiotics. You're killing your gut bacteria, which is having all kinds of adverse effects. So stop demanding antibiotics, please. Well, you're also selecting for resistant bacteria. So if you do get a bacterial infection, then you're limiting the number of antibiotics that we can use. Okay, back off of my rant, back onto the study. So once they stopped the antibiotics, that enteric nerve population rebounded within 2 weeks of antibiotic withdrawal. And they found that the nerve cell loss was induced by depletion of the microbiome. And that depletion of the microbiome activated inflammatory pathways, specifically dealing with cell death. And one of the nerve cell types that they found was decreased was CART. And this is really interesting. So stimulation of CART results in increased blood sugar, decreased insulin levels, and a reduction in food consumption. So this seems to be a homeostatic pathway that we can regulate our blood sugar without needing to intake excess calories. So these CART neurons have a direct connection with sympathetic nervous signaling and stimulating the pancreas to release glucagon. Glucagon helps raise our blood sugars and inhibit insulin signaling. It can also drive the liver to make more sugar, a process called gluconeogenesis. And then glycogenolysis, which is glycogen is how we store sugar in our muscles and our liver. And so you free that up to get into the bloodstream. It was interesting. We don't really know yet what these CART neurons respond to. Is it sugar in the gut? Is it other signaling molecules? Is it movement in the intestines? And this is just theoretical. There's no evidence that I know of this. But it seems to me like these are the type of neurons that would be active in a fasting state. They'll be active when food isn't coming through the gut. Because you would want to know that. Your nervous system would want to know that there's no food coming through because it has to regulate blood sugar. We need a certain amount of sugar in our blood, a certain amount of glucose in our blood to function normally. That doesn't mean you need to go eat a whole bunch of carbs. No, your body's very capable and very efficient at making sugar. Very efficient at it. And it's very efficient at regulating its blood sugar if you allow it to be. So I theorize that these groups of nerves are important during fasting time periods, during time periods where you're not fed. Because it seems like these nerves are signaling that, hey, we need to regulate our blood glucose outside of caloric intake. So we'll be on the lookout for more research on this type of pathway. But I think it's really interesting that our gut microbiome influences what our nerves are doing and how our nerves are helping us maintain homeostasis, maintain balance in that normal functioning, and how dysbiosis or damage to the microbiome can influence what our nerves are doing to keep us healthy. So let's move on to the final segment. We're still in our routine series. We're talking about vitamin B6, pyridoxine. So what does it do? It's a cofactor for enzymes involved in sugar metabolism. It's involved for the synthesis and metabolism of neurotransmitters, brain chemicals, specifically serotonin, norepinephrine, and dopamine. It's involved with making heme, which is the protein that carries oxygen in the blood. It's responsible for vitamin B3 synthesis, niacin. It's responsible for making precursors to what goes into our DNA, for making red blood cells, for detoxification. It's also involved in the metabolism of fats and fatty acids, and it's involved with making antibodies for the immune system. It also has some antioxidant and anti-inflammatory properties. So there are multiple types of pyridoxine. The active version is something we call P5P. However, the absorption between the different types and the different forms is the same. So sometimes you'll see it as pyridoxine or B6. Sometimes you'll see it as P5P, the activated version. Deficiencies can be caused by chronic alcohol consumption, diuretics, estrogens. You're hearing that a lot. The birth control depletes a lot of the B vitamins. And that's why anybody I know who's on birth control needs to take a B complex. Period. Some of the TB meds can cause this, and so we give it with isoniazid, one of the tuberculous medications, and one of the medications we use if you have a positive TB skin test. Some of the Parkinson's meds can cause this, L-Dopa, digoxin, and then also I forgot to mention that B6 is involved with thyroid function as well. So just add that onto the list. So what are the symptoms? It can be neurological symptoms if you're deficient, irritability, depression, seizures. You can get inflammation in the body, inflammation in the mouth. It can be impaired function of the immune system. It can be elevated blood sugars, abnormal cholesterol panels, and increased homocysteine. What are the food sources? Salmon, ricotta cheese, tuna, eggs, beef, poultry, green beans, bananas, chickpeas, avocado, sweet potatoes, spinach, carrots. Those are some of the common food sources. So because it's in a lot of foods, deficiencies are quite rare unless you're on medication that can cause it, or if you have a very high processed food nutrition plan, which is a lot of people. Testing, oh man, see, there's a lot of testing that you can do for B6 levels because it's involved with so many different things in the body. I'm not going to name all of them, but you can test a lots of various amino acids. You can test the neurotransmitter levels. You can test the B6 levels itself, something called quinolinic acid and kyurinic acid, which are involved in tryptophan metabolism. So there's a lot of different things that we can look at to make sure that the B6 level is doing what it needs to do. So the RDA is 1.3 to 1.7 milligrams per day for adults, depending on who you ask and where you look. Supplementation doses vary dramatically. You'll see as little as 5 milligrams up to sometimes 250 milligrams. Usually we don't recommend more than 100 milligrams for extended periods of time. And that's because of side effects. So some of the side effects can be nausea, vomiting, heartburn, diarrhea. In high doses, above 100 milligrams, it can cause allergic reactions, specifically skin allergic reactions, and paresthesia, so you can get numbness and tingling from high doses. Well, this has been Wellness Journey. Well, not Wellness Journey. This has been Wellness Weekly number 3. You guys digging the format? Let me know. But we'll continue next week in our routine series as well. And then we'll have 2 more studies and another wellness journey. And again, we will be taking some time off around the holidays. So we won't have any releases for about 2 weeks. I think the last day I'm going to release on is the 17th. And then we'll be off until January 4th. And we're going to start up the new year with a podcast on the growth mindset. That one's going to be awesome, really timely to help you guys out with your resolutions. Don't get me started on it if I believe in resolutions. I don't. There's no time like the present. I'm not going to put off starting something till a specific time period if I think it's going to help me. But I know that's what a lot of people do. Thank you for listening to the Strive for Great Health podcast with your host, Dr. Richard Harris. Have a blessed day.